Hi, my name is Jamie Hardin, and thank you for tuning into my video about data analysis, or also called data analytics. So let's go ahead and get started on what exactly is data analytics. So, data analytics is the process that includes inspecting, cleaning, transforming, and modeling data with the end goal of ultimately discovering useful content. So, pretty much in layman terms, it is the process of cleaning and sweeping through data, hoping that we find some use for information that can be used for either modeling or for businesses, for instance, to predict future goals. The data that is being discovered is usually used to support important decisions for both developers and also businesses, especially for businesses and managers. Data analysis has multiple approaches and encompasses a variety of different techniques as well. So next, I'll talk about data mining, which is an interdisciplinary subfield of computer science, but also a very part of data analytics. It is the computational process of discovering patterns in large data sets involving methods at the intersection of artificial intelligence, machine learning, statistics, and database systems. The overall goal of data mining process is to extract information from a data set and transform it into usable data so that the people who is actually extracting the information can then use it. Aside from the raw analyst step, it involves database and data management aspects, data pre-processing, model and inference considerations, and also the complexity considerations. Data mining is also the analysis step of the knowledge discovery and database process, or KDD. So, as I said earlier, the knowledge discovery and database process is commonly defined with six stages. Those being selection, pre-processing, transformation, data mining, interpretation, and then evaluation. However, in many variations of this theme, such as the one done by the cross industry standard processing for data mining, they actually simplify this process into three easier steps, which I will do in this PowerPoint, and they are pre-processing, data mining, and then results validation. So the first step is the pre-processing step, which must be done before the algorithms can be used. A target data set must be assembled before we can get to those algorithms that help us predict these models. As data mining can only uncover patterns actually present in the data, the target data set must be large enough to contain these patterns or remaining concise enough to be mined with an acceptable time limit. A common source for data is a data mart or data warehouse. Pre-processing is essential to analyze the multivariate data sets before data mining. The target set is then cleaned. Data cleansing removes the observations containing noise and those with missing data. So it helps remove the information that we really can't use. It's kind of just there, all of the junk data. Then we go into data mining involves six classes of steps, which you can see. The first being anomaly detection, the second being association rule learning, the third being clustering, the fourth being classification, regression, and then summarization. Two of the most important, a lot of people consider classification and clustering, which the main difference is that clustering is the task of discovering groups and structures in the data that are in some way or another similar without using known structures in the data. And the actual classification part is the task of generalizing known structure to apply to new data. For example, an email program may attempt to classify an email as legitimate or as spam, which again, that is a data mining process so that you don't receive all those emails that you do not necessarily want. Then the final steps is results validation, which helps us to verify that the patterns produced by the data mining algorithms are actually correct. Sometimes information can be misused on purpose, and also unintentionally it can be misused. So this helps us to figure out which of this data is actually valid. Um, After we find out which data is valid, which is not, we can then find out if these learned patterns meet the desired standards. If they do not, we then find it necessary to reevaluate and change the processing and data management steps if they do not meet our necessary requirements. So some of the utilizations in data mining, which it is used in several apps. Some of the big advances are in business, science, engineering, human rights, medicine, and then also surveillance um, as well. So in business, data mining is the analysis of historical business activities that are stored in static data warehouses. So all the information that we can't use or get to because they're stored in warehouses, data mining helps us to predict patterns for these algorithms. So for instance, data mining can be used to predict customers' purchasing habits. So like if we see a particular demographic of people purchasing this type of product, we would then want to produce more of that product so that we are able to meet the demand of that necessarily demographic of people. It also helps us produce necessary like manufacturing problems and also as well as trends in the business. Some of the huge benefits of data mining and science have been the sequences of the human genome. We now know very well what certain diseases are caused by which genes, which would not have been possible without the data mining because it helped us to discover and sequence the human genome. Also, it helped us with diagnostic tools because we now know which specific genes are caused by certain cancers and things like that. So we're able to predict in diseases and things of that nature. Lastly, and one that is most crucial to me is data miners in medicine, which it comes to the electronic health record. Right now, the electronic health record is kind of static, and we actually can't use it to only to input data, but not necessarily retrieve data from the electronic health record. By data mining, it allows us to open a vast door of a huge medical data analysis. We can then use the healthcare record to actually predict the treatment of a patient and also to overall just improve the quality of care given to a particular patient. It can also help physicians with the treatment of care instead of just be used as a place to store information. It can actually be used as something that can help us improve the care of all of our patients. So some of the big advantages, not necessarily just in a particular field, but overall, has been the improved company revenue and the lowering of costs because we are able to predict what our customers may want. We are not necessarily overproducing certain products, and that helps to create with so we're not having too much inventory. Also with fraud detection, and again, one of the main goals and big benefits is that it predicts future trends. Some of the disadvantages is that the amount of data that can be censored and sifted through can sometimes be overwhelming. So it takes a wide variety of people and infrastructure to actually put into place to make sure that these systems are operating correctly. Sometimes the inaccuracy of data, like I said earlier, we can use this data can be misused, algorithms can be incorrect, and we may not be looking at the correct trends, and we may make a wrong decision because of the data that is being used. Again, thank you for tuning into my video about data analytics. As you can see, this is just a small portion of the vast amount of things that we can do with data analytics. It is very important for business, and you will see that a lot of business are actually switching to data analytics and starting to do data mining because of the vast majority of benefits that they can reap from doing so.